Hello, everybody. My name is Wilfried Roosen. I'm from Belgium, and I'm a blacksmith independent for 5 years now. I learned my skills or the job. I learned it in Brussels under Peter de Bruin. And yeah, as I say, I'm not the master I've seen here before, but I try to always try to add some forging into the job that I or into the work that we need to make. So today Patrick asked me to speak about banning of heavy stock, and so I will try to explain it in different parts. So first, how we came, so what's the history, how we came to do this heavy stock, what are the possibilities, how can we use it, which were the problems that we need to overcome, which tools we made it to bend this stock, and then you'll see some parts of end results that we made, and then of course we will end the presentation with the questions. So when we start at the history, so what was the thing? So I got a customer of mine, and he asked me to create a gate, and he had seen it on internet from a colleague blacksmith, and the picture here is the gate I made. But you probably, if you have the books of metal art, then you will know there is a colleague of us who made this gate. So I thought, okay, good. I give him a call because I think it's the proper way. I give him a call. I asked him if it was okay for him that I would create a similar gate. And since we are like 900 kilometers from each other, he said it's okay. Try to put your thing in it, and but yeah, I got the okay to make. So that was somehow awkward for me already to ask a colleague if I could go a little bit his way, and yeah, then I thought, now I'm not going to ask how did he made it. So that was a little bit of a bridge too far. So I said, okay, that's the thing we will do here. And we met the team and we talked together. We saw what the possibilities were and where our problems would be during the process of making. The first thing we needed to make was the bending of stock from 200 on 10 millimeters and plus minus 4,000 millimeters long. So 20 centimeters on 10 on 1 centimeter and 4 meters long. Later on, I got a commission for a city here to make an artwork, and that was even bigger. So it was bending of 400 millimeters wide on 10 millimeters thick, and the length was plus minus, let's say 3 meters high. So yeah, I needed to find a way to bend both those stocks, and it was necessary to bend at least 10 millimeters thick and up to a wideness of 400 millimeters. Afterwards, you see, you can use it to build stairs. Now I got a commission in a nearby city where we needed to build 4 stairs, and I will use the same technique to build the stairs. We made the handrails, we made the gate fences, and then we need RP. So as a matter of fact, you can use it for everything as your mind, when you put your mind into it. Okay, so what were the problems that we needed to overcome? So at first, it's the thickness of the material. It's 1 centimeter or 10 millimeters thick. It's the wideness of the material. It's at least 200 millimeters. It was the length of the material, and because all those 3 above, it's of course the weight of the material became also a little problem, because we needed to go from the fire onto the tool we made. And then by bending it, you should have, because you made more than one piece, you should have you need to have equal bends on every piece. And you will see, like when we created the gate, the angles or the square bands needed to be exactly the same as well. So in angle as in thickness. So that was important also. Then heating over the wider width. So for 200 millimeters, it's okay. But for 400 millimeters, it's already something in the normal fire, because we have a normal fire here. And then we learned during the process that actually the cooling down on the correct spot is really important. So these were a bit the problems we wanted to overcome before we made it. So we made two tools. You see a vertical here and you see a horizontal here, which both are put into are connected with the ground, with the floor of our forge. So we can use we have the power of the floor of our forge. So the first thing we made was bending in a straight line the 210 millimeter stock in straight line. So therefore we created this tool, the same as for bending in an angle, which you will see later. So actually it's the plate here in the middle is the stock of 210, and we made it on such a way that you can put another stock inside it. It will go inside, so it comes out of the fire and it goes inside of here. This is like how we banded it. So normally this piece will be straight. So it goes in, it comes from the fire straight in here. We fix it here, and then we bend it upwards. So you need to, once you've bended it or you start bending, there are two or three things that are important. That's that the material stays in place, but also that the bend is straight, so that you got a 90-degree angle here, and but also that the how will I say, that the angle here stays on all sides 90 degrees. So that was a bit in the beginning, it was a bit or it were the problems that we faced and that we came upon when we bended the material. So what did we do? Patrick suggested, and there he was right. So why didn't you make a stop so that you didn't need to calculate every time how deep you needed to put the material in there? But I asked myself, okay, why didn't we do normal stop, and why did we fix it in the hole? That's because the first time when we have bended it, and when we put the iron inside, we bended it, it came a little bit back out of the tool. So then we decided, okay, no, we will put it in there. We do the measuring, we drill the hole, and so in normal situation, this goes here, this goes in this piece of steel goes in this hole, and the stock will stay on its place, and then you will bend it upwards. And so for bending it upwards, we created this so that it will bend in a straight angle as well. So throughout the total of the width, because you don't want to give it a wrong angle in bending it. So we created this tool which will slide over the stock, and you will bring this upwards, and then the stock will bend also upwards. So that's the thing. Important is the cooling down of your stock. So this part, the part on the left side, on the right side of the first angle of the first arrow, will go into the device. So that's no problem. That can be hot. It's no problem. The part on the left side is the thing. Also, when you bend smaller stock, so if it's too hot until here, then it won't bend right where you want it to bend, but it will bend also here, and you don't have the right corner, of course. So that's a little bit about the bending in a straight angle. That's we use now for together with the gate to make a fence. That the stocks are in the paint shop, so I can't show you at this moment, but I will show you the end result later, and I send a picture to Patrick. Okay, so then we came by bending the 210 millimeters in an angle. So, and there we said, okay, we started from our actually device for our initial tool, and we needed to bend it on a degree of 45 or on an angle of 45 degrees, plus the height needed to be every time the same. So in between the two stocks, when you bend them, you need to have a certain height. So we took a bar of 6 centimeters, 60 millimeters high, so that we always had a bend of 6 millimeters. So what we did was, I speak here about these bends. So you see the stock goes normally straight down, so you don't need to bend it 90 degrees upwards, but you also need to put it 45 degrees in an angle. Those were, and you need to have the space here, needs to be the same here as well as here, as on the other stocks. So that was a little bit the challenge we have. So what did we do? We created this piece that we put on the initial device. The stock will slide underneath, and then you will bend it upwards and to the right, on the other side to the left. So you see here, this will be the space. So what did we do? We took the thickness of the stock plus 3 millimeters, because when it comes out of the forge, it's a little bit thicker, so it needs to go smoothly in the device. Plus, because it was 2 meters plus minus on each side, you have the stock already bending coming out of the fire. So, and this needs to go you don't have like 3 minutes time to bend it and to put it straight, because when it's bended, you needed to control if the angle was 45 degrees and 6 centimeters high. So good. So here you see, so I took a little piece that we had, so it goes in here, and we bend it straight over this steel bar of 60 millimeters, so that we always have the same thing. Now, to do this bend, you want to have a clean bend here. How will I say, when you do it by hand, then this bend is never clean. So what did we do? We made this device like a guillotine, who has the 45 degree angle, and who goes over the device, and then with 2 guys you bend it and you turn it. So this will be the how do you say, this will be the bend here, and this will be controlled over the full length of your stock. Here you see again the hole which lets the stock stay on its proper space. This I go back. So here you see, this is the device we put on it, and this is then the end result of bending of the stock. So for the gate, you must know this here goes like 2 meters on the right side wider, and this goes like 2 meters up. So that was a little bit the thing. Then we got another commission from the city, and there we needed to bend 400 millimeters on 10, not on 100. I thought I changed it, but on 10 millimeters thickness. So it's 400 on 10 and not 400 on 100. But we needed to make a chair. So this was bending left and bending right. So you couldn't make it on a horizontal tool like we used for the gate or for the fence. So we said, okay, good. Then we're gonna use actually plus minus the same, but we will put it on a vertical stand. You can see here we got this bend, and then we get the more than 45 degrees, of course, bent, or 90 degrees bent down. And now when you put it on a horizontal tool like from which we started, then this will give a problem because you cannot bend this one. So we said, because you need to control it as well. So we said, okay, good, we will bring it vertical, then we can control it. So how do we do it then? So this got the full length, it's got the same thickness as the material, plus 3 or 4 millimeters, and we made us this device as well. Why? The plate goes in here. We can control the bending because of this thing here. Because when you try to bend it and you go up or down here, your bend will not be correct where so you won't have your correct angle at the end. So we needed to have something which stayed on the same level to start from. So we need to have this. You see, this is 10 centimeters from the floor. So we needed to have at the end the same 10 centimeters from the floor. If not, this would go a little bit not straight again. So we made for us this device here, and here you get the measuring horizontal on the floor, and we go and we make the bend like that. So this is here the end result in bending. So these were a little bit the problems during the stage that we find. That was first of all bending over the full length, and then having a nice bend on the two articles. So normally here comes the other one, and he goes here and he stands like this. It's a chair, which I will send a picture because the community is placing them next week. So I don't have it anymore, but when it's ready, I will put a picture as well. Okay, so these are a little bit the end results. So this is the bending of the material, of the straight material, and you see this was used or we made the fence out of this. This is one part of the chair, so the other chair is coming on the back end of it. This is the gate and the smaller door. So you see we needed to make 1, 2, 3. Here you got 4, and here another 3. So we needed to make 10 bands who are equal. So that was a little bit. That was a little bit difficult. That's another. And then we had a commission in Hasselt, in a bigger city, and there we needed to make hand railings. So I actually used the same technique. So also here is the bending of the stock, the normal bend, and then when you see upstairs, we took this 45 degrees and we went down. So here you see it. So we bend 45 degrees, and then we go down with the angle of the chair. And here's the same. You got 90 degrees, and it goes like, I don't know, 30 meters or something straight on. So it's all not the traditional way of forging, but yeah, we try to take forging with us to build a new gate or a new handrail here, so that the people. So this was also forged here on the spot. So then you see the people are coming to look because they don't see it anymore. Because I wanted to have the right angle here downstairs to the stairs. So we made this on the spot.
First comes from Lars Janssen. What did you mean by normal fire? How big was your fire to heat the stock precisely? Was meinst du bei normalem Feuer, also bei einer normalen Feuergröße? Wie groß war das Feuer, um dieses Material präzise zu erwärmen?
We have a normal fire for us. It's like an angular fire from, I think it's like 10 centimeters wide or something, and I don't know, 20 centimeters long. And okay, then was the problem of, well, not the problem, but then was the question, of course, okay, how can we go to heating this width of 40 centimeters? The width for 20 was still okay, but 40 centimeters, because you need to have the exactly heat on the full width. So then we went first heating up in the center, and so going left and right till we had constant and equal heat over the full width of the stock.
Wilfried hat eine normale Feuerschüssel, wie man sie bei Angela erwerben kann. Und diese ist etwa 10 mal 20 Zentimeter breit oder etwas in der Art. Und bei dem normalen, also bei dem kleineren Material, 200 mal 10, war das kein großes Problem. Allerdings das größere Material hat er dann in Feuer von rechts nach links bewegt und wieder zurück. The next question, bei Robin Muth. I often see white flat stock dishing out a bit when bending it. How did you deal with this? Ich beobachte häufiger breites, flaches Material. Biegt sich in den Ecken ein bisschen nach außen. I think one can see this on the picture, Robin, right? On the right side where it's going down. So, wie bist du damit umgegangen?
Here you almost don't see it. So here, this Robin means that the bend here and on the both outsides would go a little bit out. Yeah, would not be straight. Or am I?
There's some kind of curve.
Yeah. So therefore, we created this device. So it's like you put it in there, and this is the full brightness or width, the full width of the piece. So this goes over it, and the piece goes inside it, and it was banded from here till there. So this is like how did you call it last time, Patrick? It's like the liver. You put this in there, and you can it will bend over the full length, and it will take the full length. It will not bend, but it will take the full length of the stock. These are also examples. So we tried a few before making the gate, because it was not that we put there one piece in the fire and there was a gate. we were trying 2, 3 before we had the right solution for us.
Also geht damit also die Hebelwerkzeuge, die hat, das hat man bei dem 400er gerade ganz gut gesehen, und hier sieht man das auch ganz gut. Der Hebel wird über die komplette Fläche angesetzt, und dadurch wird dieses wie auch immer es auf Deutsch, also dass die Echsen so ausfransen, ausschwingen, wird dadurch minimiert. Did this answer your question, Robin? Ausbechern. Genau, dadurch wird das Ausbechern der Ränder minimiert. Did this answer your question? Hat das deine Frage beantwortet?
Ja, auf jeden Fall.
We're going to the next question, which is from Paul Voss. Is it structurally rigid enough in the corner? Ist es strukturell stark genug oder fest genug in der Ecke?
Yeah, the gate. I tried to wait. I go. I tried to show you. This gate is only put together with on the back side. It's not that we didn't make.
I think the question was more, Wilfried. The question was more in that direction, that the design as such and the width of the design invites other use than as a handrail. young people, for example, could use it for skating.
Ah, yeah.
Is it structure or a slider?
Yeah,
Is it structurally safe enough for that kind of purpose?
In Hasselt, we noticed when we went back to the control on the to see if everything was still okay, that they used the handrail for skating. But here you see that's why I come here. This is not made with a frame. So this gate are actually 1, 2, 3, 4, 5, 6, 7 pieces of its own, and here. The only thing we did was we put we needed to put spacers at the back side. So so every piece is only held together with bolts. So it's not that this is made on a frame. The same with here. You see, this is not a frame. There's no frame. So the plates are exactly are the frame. So okay. This won't bend. The problem you will see is when I go back to Hasselt, you see this here. You see? So over the length, we needed to put here you see it also a little bit, that because of its own weight, it would bend a little bit, and there we put the T bars underneath. So to give it an extra what do you say? You have to give it an extra strength. Yeah, but yeah. The kids used the handrail to skate.
Okay, so I try to translate this. Die Frage war ja, ob das zum Beispiel, wenn man da drüber skatet oder das als Rutsche benutzt oder so, ob das so einer Belastung standhält. Und die Antwort ist ja. Sie haben festgestellt, dass genau das passiert ist und es hält nach wie vor. Allerdings wurden zur Verstärkung T-Profile darunter gesetzt. Das sieht man hier, zum Beispiel da, wo gerade die Hand von dem Cursor ist. In the corner of the armrest, I don't see the T-bar because the corner as such is stable enough. But the stiffness is needed over the long ways, yeah, and that correct. It's stiff enough as such. You can see in the gate, which Wilfried then earlier showed. Und dann hat Wilfried zwischendurch das Tor gezeigt, was nicht auf einem Rahmen aufgeschweißt ist oder so, sondern dass die einzelnen Elemente sind verschraubt und halten stabil genug aneinander. Das ist also die Konstruktion an sich ist stabil, nur eben über diese langen Strecken biegt sich das flache Material durch. Lars Jansen is asking, how long did it take you to work out these solutions? Die Frage ist, wie lange hast du gebraucht, um diese Lösung zu erarbeiten? Wahrscheinlich auch how many trials, and hopefully also how many trials.
Yeah, it was really
wahrscheinlich auch wie viele Versuche benötigt.
It was a trial and error. So so the straight bending was of course not the problem. That was not the problem. The problem was when we started bending it in the angle, and the first time we bended it without the device there, I forget of the lever or how do you call it, Patrick? Then you saw that the angle wasn't correct or the thickness wasn't correct, or so we knew, okay, we needed to have a device that controls the bending. So, and then we came with this what we made, and okay. Then it was okay. You could control the bending from each side to the other side, and then it was so. How many times? I don't know. It was, let us say that we had it. Took us half a day or something before we put everything together and find a solution or. Let's go there.
Ungefähr, also er ist sich nicht ganz sicher, allerdings alles in allem, also zuerst musste man natürlich herausfinden, wie man dafür sorgen kann, dass die Biegungen immer konstant bleiben, und dazu wurde dann eben dieser Hebel erfunden bzw. herangezogen, und wahrscheinlich hat alles in allem etwa einen halben Tag mit Versuchen gedauert. When you were bending this 400 millimeter wide stock, Did you also have rest or something further into the stock on the end which was moving, or did you just use the lever?
Wait. I don't.
Hast du, wenn du das schwere, also das 400 mm breite Material gebogen hast, maybe it's good to change to the picture where you are showing this bending machine or bending device. Hattest du dann weiter hinten im Material? Yes, exactly this picture. Yes, great. Hattest du dann auch weiter hinten, genau ungefähr da, wo die Hand ist, oder noch weiter eine Stütze, damit das Material nicht nach unten wegsackt? Oder war die Stütze an dem Hebel ausreichend?
Yeah, we were always three, huh? So we were three persons. It was not that I did this alone, because that's impossible. So because you need to two guys put the material inside. You got one who controls where it should stop. This is 40 centimeters in like 700 degrees. It's already a hot. It's already a heat that goes alongside. So then we had this guy who put the material inside, so the end pin inside. He would use this device to bend it. And here we put like 10 centimeters underneath to follow it. You understand, Patrick? So we put a bar so the same bar here we put underneath, and then we would bend it also together. So for all insurance, because when this goes not straight, then you have a problem at the end, because you cannot put it in the fire again, and you cannot bend it again. You technically you can, but it's you want to have it first time correct.
Ja, die Antwort ist, es wurde ein Stück Rohr entsprechend dem anderen Stück, was da unten drunter ist, also in dem Falle 10 cm, untergelegt, damit die Biegung gerade erfolgt, damit man das nicht später korrigieren muss, weil das auch relativ schwierig geworden wäre, das später zu korrigieren.